Hello and welcome to the CXC with VMware Take 5 webinar presentation. In today's presentation we're going to discuss using the CXC system with VMware in the new short webinar format. The presentation should last about 10 minutes and there'll be information at the end on how you can ask further questions and get more info on the product. In order to understand how CXC works within the VMware environment, it's first necessary to understand the functioning of the server components in a standalone system. If you look at this diagram, you can see CX can be deployed with a high amount of redundancy based on its own internal features. In this particular diagram, you see there's two system servers or control servers that would be running in active-passive mode, and multiple call servers, the actual application servers that connect to the phone system. In this environment, without any VMware implementation, the system is still fully redundant. In other words, any system component can fail. The system will continue running with all functionality. The two system servers are running in active-passive mode. If the active system server fails, the passive one automatically takes over. And now, as we look at this is one of the ways to deploy without VMware. Now we're going to look at adding VMware into the mix. The full CXC capabilities can be implemented in VMware. The product has been taken into the VMware lab and fully certified as VMware Ready. So every component in the system servers and call servers we looked at earlier, and several of the application servers, can be deployed within a VMware environment. Now there's a number of options on how you would do that. We're going to look at those in the next couple of slides. But it is good to know that everything we have can be supported in a fully virtualized environment. The one limitation to keep in mind is the fact that some older integrations to telephone systems might require line cards to be installed in the call servers, in which case those call servers could not be virtualized. It's also possible to not use the line cards and use external boxes, dialogic media gateways. So there might be some discussion in terms of how it would be virtualized based on your telephony infrastructure as well. The second issue to keep in mind is CXC uses a software dongle on a USB port for software security. The next couple of slides will take a look at how that gets implemented in a VMware environment. The first supported method for supporting the security dongle on CXC when it's virtualized involves using the VMware technology DirectPath I/O. With DirectPath I/O, the dongle can be installed on the physical platform that the CXC system server host is installed on, and then the connections can be made within the VMware software to map our application directly to that USB dongle. This is fully supported and indeed using software developed by VMware, and we have numerous instances where this is in play. So this would be one of the two ways to support the dongle when you're using VMware. The second method for supporting the dongle in VMware is to use the third-party product Anywhere USB. Anywhere USB is a network appliance that sits out on the network and allows connections to be made from within hosts out across the network to devices installed in the Anywhere USB platform. In our case, we're going to install the dongle on the USB Anywhere device and go into our software and map our dongle out to that physical dongle on the network. USB Anywhere has been deployed in thousands of installations. It's a well-tested product, and it's been tested in our labs and certified for use with VMware and the CXC system. So that's two ways to do it, Direct I/O or Anywhere USB. When the time comes to implement CXC within the virtualized environment, there are several choices for architectures, and these choices offer different levels of redundancy, different levels of control. In this first slide, what we'll look at is actually taking all the separate components of CXC, system servers, whether there's one or multiple system servers, and the call servers, and virtualizing each of them in their own host. And in this type environment, basically you're going to have all the CXC functionality embedded inside of the VMware environment. Now this includes the ability to put in multiple system servers, as we discussed in the first slide, for things like automatic failover and geo-redundancy, but they're all implemented on their own host within the network. And this is the typical network where the customer is not using a SAN in terms of to map the databases external to the hosts. Now, this second architecture assumes that the hosts are actually mapped to data stores external to the physical platform, out on the customer's network on a storage area network. And what you do in this case is you install the system server on a physical host. You connect it to the dongle using, once again, anywhere USB or direct path I/O. And that system server boots and is running off of that drive that it's mapped to on the storage area network. You now go to a separate physical host and you load another instance of that same system server, and you load it off of that same drive, that same mapped drive on the storage area network. Now, in the case of this kind of implementation, only one of those system servers is running at a time. So system server 1 would be running on the first host on host 1. If it failed, the administrator could go shut it down and bring up the second copy running on host 2, which would automatically connect to that same mapped network drive, so it would have access to all the current database settings and message store, and bring that up to speed. And in this case, you'd move the physical dongle across whichever type of mapping you were using, and you would now have a full virtualization such that you could have the ability to bring a second system up if the first system failed. Now, in this type of architecture, the failover won't be automatic. It'll take anywhere from 15 minutes to half an hour to shut the one host down, bring the other host up, get the connections going again. So you don't get automatic failover, but you do get a virtualization copy that can be used. And because of the storage area network being used as the data store, it's going to be an accurate copy up to the point where the first host failed. Now, this third implementation is similar to the last one, only we're going to assume that the primary host is in one location and the secondary or backup host is in a separate location, geographically dispersed. And in this case, the functionality is the same. You load both hosts running off the same drive. When the main host fails, you will bring up that remote host and it will take over the functionality of the system server. This does require that that secondary host have access to the SAN one way or another, whether it's through replication or mapping, so that it can boot from the same image that the first host was running from. And now the second challenge here is the dongle. Assuming this is geographically dispersed, you don't really want to have to move the dongle. So we offer the ability to purchase a second dongle that can be used to drive host 2 when it's brought up in the place of host 1. So you have the same kind of redundancy here with a manual switchover, but it does require two dongles rather than having to move the dongle from one physical location to the other. Having determined the type of implementation you're going to use, the next step, of course, is allocating the resources as you configure the VMware hosts themselves. And we've made this fairly easy to do in terms of understanding the various configurations of our system. Now, depending on what the system is doing, what our system is doing, how many ports it has, which applications it's running, there are different sets of requirements. Even outside the VMware world, we would talk about server requirements and memory requirements, varying based on the size and complexity of the system. So within our documentations, we actually have published statistics for what you would need. Now, if you look at this slide, the concept would be, in order to configure the VMware host, you'd first review our software release notice for the software version of CXC that you were running. And from there, you could identify the hardware requirements in terms of processor and memory needed. And then you use those to go in and configure the host, and then basically the components get installed, and the monitoring process for our application is exactly the same as it would be for any one type of application running within VMware. So if we look at how we get to these numbers, where we find these in our documentation, we actually can look at the charts that we have that are available within each software release to tell you specifically what you need based on the application you're running. To determine the host requirements, the first chart you would use is the recommended hardware by server class. The recommended hardware by server class will tell you based on the size of the system, the function type of the server, system server, call server, etc., and the type of applications that are running, number of ports as well as number of speech resources, and it will then tell you exactly what the requirements for the physical server would be, and these carry over exactly into the VMware host configuration. So you can see on this chart, we've configured 4 types of servers. Each type of server has a different processor type and a different amount of memory. And you would go through first and determine which class of server would be required. Having determined the server class, you would then go to the server class configuration page in the software release notice, and it would tell you exactly what type of server that class represented. So as you can see, each of these servers has a slightly different configuration in terms of processing power and memory. And if you look down to, let's say, server class C, you can see that it would be the equivalent of a dual-core Intel running at 2 gig. Or the various equivalents of that. Using that information, you then can go in and configure the host. Within our installation document, there's a section on configuring with VMware, and it not only includes the details in terms of how to do this, how to configure the host, but it also has guidelines for performance and troubleshooting, how to use the basic VMware tools. You can see this is the virtual machine real-time chart where you can monitor usage. The one thing that is slightly different in a real-time voice application than many of the other applications you might have on VMware is the need to have direct access to the application at all times. Whereas a database application, if it ran into resource problems, could simply play an hourglass to the user for that few seconds until it could get the resources it needed. Our system can't do that. We're answering a call and there's a live person on the other end that has no idea about system delay. So we have to ensure that we have the access we need on that physical host. And one of the things that's somewhat problematic, particularly on a larger implementation, is no matter how much processor and memory you can support on that host, there is a natural limit to the data bus in terms of the number of voice over IP conversations you can run on that platform. And so there may be times where you simply can't put other applications on that same host if the call server that's running is large. I'm talking fully deployed call servers, 96 to 144 ports. In that range, there may be limitations. But the tools are always there, and the troubleshooting techniques that you can work with our tech support people can talk you through and figure out exactly what's going on. We talked in the beginning of the presentation about 3 separate ways to implement CXC within VMware. And each of these has a slightly different feature set. And it has both different features in terms of how it works and how it's maintained. So really quickly, we're going to go through this chart and talk about the differences between those so you can decide which type of implementation would be appropriate for you. So if I take CXC, just the basic servers, and load them each component into its own host, basically you have some features and functionality there. If it's a simple implementation, there won't be any auto failover. It'll be more manual because you're dealing with both the VMware piece and the CXC piece, and there'll be a little bit more labor to put it in. But on the plus side, that is how you start, by reducing the hardware needs for CXC, and the familiarity of the VMware people themselves make this an attractive solution for some types of deployments. Now remember, we also talked about deploying CXC with its own failover capabilities outside of VMware. So no VMware involved to get redundancy. And in this particular type of deployment, you get the automatic failover functions, the ability for everything to run real time even after there's failures. You also get no intervention for the failovers and some of the failback types, and it's very much less labor to just deploy it this way. The downside, of course, is since you aren't taking advantage of VMware, you aren't getting to reduce the hardware, and you don't have the familiarity of having everything within your VMware environment. So while this adds more in the way of functionality, it's not really very attractive to people who are running a VMware environment. Now in the last column, we sort of get the best of both worlds approach. If you take the CXC architecture itself and configure it for failover with multiple system servers and multiple call servers, and then place that entire implementation into VMware with each server on its own separate host, you now get the advantages both of the VMware functionality, the familiarity, the reduction of hardware, plus the CXC automatic failover and no intervention in terms of keeping the system up and going. So this is perhaps for true redundancy in a VMware environment the better way to do it, and certainly the more feature-rich way to implement. So you have your choice of any of these types, mixing and matching the various components, and keep in mind all of this has not only been tested, but has been certified by VMware as VMware Ready. So as we wrap this webinar up, we'd like to thank you for attending. We would also like to kind of reference the fact this is one of our short format webinars. It may very well have raised as many questions as it's answered, and that's fine because you can get in touch with us for more information. Here on the contact screen you'll notice you can go to our website. There's white papers and a lot of explanation on all this technology, but you also can address questions to us directly by sending them to info@avst.com. And based on the question type, the correct resource will get back in touch with you. If you have a technical question on how this works, sales engineering will contact you. If you have an interest in kind of pursuing and looking at the pricing structure, one of the regional account managers might get in touch. So the contact capabilities are there for us to solve whatever your questions are. Once again, thank you for attending, and we hope to see you in further webinars.